Welcome to the second video of this series. After successfully creating the base plate, we will now begin constructing the cylinder head plate. You could create these with the commands you already learned, but we want to introduce you to some more useful functions. Let's take a closer look at the component first. The cylinder head plate is axisymmetric, meaning its geometry is mirrored along an axis. It has 4 countersunk holes. While creating these holes, you will learn 3 new functions: how to reuse sketches, how to insert holes using the hole tool without a prior sketch, and how to position them precisely using a rectangular arrangement. It features 4 countersunk holes. In creating these holes, you will learn 3 new functions: how to reuse sketches, how to insert holes without a prior sketch using the hole tool, and how to precisely position them with a rectangular pattern. Furthermore, you will learn how to create the differently executed chamfers with just a single chamfer element. At the end of the tutorial, we will show you how to change the material from steel to aluminum and display important component information such as mass, volume, and center of gravity. We start with the construction by clicking on File and then on New Construction as before. It is advisable to save the component right from the beginning. We assign a meaningful name to the cylinder head plate and confirm the entry. The file for the cylinder head plate is now added to our folder. To create more space in the workspace, we then close the data panel. As the next step, we create a sketch on the XY plane. We do this by clicking on Create Sketch and then selecting the XY plane in the browser or directly in the workspace. As with the base plate, we now create a center rectangle starting from the origin. And we use the dimensions 25 by 30 millimeters. The input is completed with a click of the left mouse button. This keeps the center rectangle command active, allowing you to create more rectangles. Now we create another center rectangle, also starting from the origin, this time with dimensions 21 by 14 millimeters. This rectangle will serve as a reference for positioning the drill holes later. To properly mark the reference line, we change the lines to construction lines. We could have activated this command beforehand, but alternatively, we could mark the lines now and then convert them into construction lines. To mark the lines, we can hold down the left mouse button and use window selection to select all the desired lines. It is important to note that it does make a difference whether you drag the window selection from left to right or from right to left. From left to right, only the objects that are completely within the rectangle are selected. This selection is indicated by a solid rectangle. From right to left, objects that are only partially within the rectangle are also selected. This selection is represented by a dashed rectangle. This difference is helpful when you want to select or avoid specific elements. After selecting the inner rectangle, we can convert it into construction lines in the sketch palette. Now you can directly finish the sketch and simultaneously call up the extrusion using the shortcut E. It's noticeable that our rectangle with the outer contour is automatically selected for the extrusion. Since we couldn't select the rectangle with the construction lines, now we use a measurement of 3 millimeters and see that, as last time, a solid is created. Since we want to reuse the sketch for the countersinks, we should not create the body above the sketch but below it. Therefore, we enter a distance of -3 millimeters and see that the body is generated in the other direction. Now we select the command Hole and use the sketch that we already used for the extrusion again by making it visible in the browser. The holes are placed on the side where the sketch is located. This becomes particularly clear when we activate the conical countersink option for the hole type. Under limits, we set it to all to allow the holes to go through the entire plate For the hole threading type, we choose simple. We set the diameter of the conical countersink to 6.3 millimeters. We leave the angle of the countersink at 90 degrees and choose a drilling diameter of 3.4 millimeters. We confirm our entries with OK or Enter. The component is now mostly completed. In the construction history, as last time, all our previous steps are listed. Additionally, we see that the sketch is still visible. To make the workspace clearer, we will now hide it. At this point, we would like to look at an alternative approach. Feel free to follow along with the steps to discover new features, or simply fast forward if you'd like to skip this part. First, we remove the previously created hole from the construction history. To do this, we right-click on the hole element and select Delete. Alternatively, the Undo command can also be used. Now we select the Drill command again and click on the surface where the hole is to be created. Then, we click on the top and side edge and position the hole by calculating the distance. For the top side, we use the formula open parenthesis 30 minus 21, close parenthesis divided by 2. For the other side, we use open parenthesis 25 minus 14, close parenthesis divided by 2. Once the position is correct, we confirm the action with OK. Now we create the missing holes by arranging the already created hole. In the toolbar, go to the Solid Bodies section, select Create, then choose Pattern and subsequently Rectangular Pattern. Set the object type to Features. Choose the hole element for arrangement either in the design history or directly in the model. Select a side edge of the model for the axis to determine the direction. Set the number of elements for axis 1 and axis 2 to 2 each and enter distances of 14 and 21 millimeters. Then confirm the process. If you made a mistake during input, you can simply double-click the element to call it up again and make changes. Now we are back where we were before, but through a different path. There are always many different ways to create a component. We are still missing the chamfers on the component. For that, we go to Chamfer in the Modify toolbar. First, we click on the two upper edges and enter a chamfer of 3 millimeters. Then we click on Add a Selection Set and choose the two lower edges to add a bevel of 5 millimeters. You could also have completed this step in two separate steps, by first creating a chamfer element of 3 millimeters and then another chamfer element of 5 millimeters. To correctly calculate the physical properties such as mass, volume, or center of gravity, we will now change the material of the component. To do this, we go to the Modify toolbar and make the change under Physical Material. The Material library opens where the material aluminum can be found in the Metal folder. To apply the material to the component, we simply drag it onto the body. After the material has been successfully changed, we can view the component information such as weight, volume, and center of gravity. For this, right-click on the component in the browser and select Properties. Here you can now see the updated data of the component, including the weight, volume, and center of gravity. We save the component again. Congratulations! You have successfully created the second component of our compressed air motor. You have the opportunity to review the entire construction process to understand all the steps precisely. First, you learned how to reuse sketches. Additionally, you learned how to create and arrange holes without a prior sketch. Creating multiple chamfers in one step is now familiar to you, and you know how to adjust the material of a component to display details such as mass, volume, and center of gravity. In the next video, we will focus on constructing rotationally symmetric components. Good luck with the next components.